This is Math 2, 12.2 notes. That's Math 2, Unit 12, Lesson 2. The title is Inscribed Angles. An inscribed angle is an angle whose vertex is on the circle. What does that mean? All right, I'm going to draw a picture and then we're going to review because we talked previously about a central angle and how is an inscribed angle and central angle different. Okay, so here's a circle. The vertex is on the circle, so not at the center, but on. So it looks something like this. I'm going to call this A, this B, and that there C. Okay, so this is an inscribed angle. An inscribed angle is an angle whose vertex is on the circle, not at the center, but on. And the formula for this is the measure of angle BAC is equal to half, is equal to half the measure of arc BC. Okay, so the measure of angle BAC is equal to half the measure of arc BC. Now we could also think of it this way, that if you double the angle, BAC, it'll equal the arc. So if you double the angle BAC, it'll equal the measure of arc BC. All right, so half as big or twice as big, depending on what you're looking at. The angle is half as big as the arc, so if I double this, it's going to equal the arc. Okay. All right, so central angle. What was central angle? So that's going to be a quick little review. We did this in our previous lesson. The central angle was like this. When the vertex was at the center, I'll also call this A, B, C. And when it's a central angle, the measure of angle BAC is equal to the arc, to its corresponding arc, BC. Okay, so it's equal to half the arc when it's inscribed, and it's exact same as the arc when it's a central, so you need to know the difference. Okay, examples. Number 1. Let's draw a picture. That point there is B, this point here is A, and this point here is C. So these are just chords. That's not diameters or radius or anything like that. It's just two chords. All right. I'm going to give you that this out here is 140 degrees. And what I want you to find is the measure of angle A. The measure of angle A equals what? Okay, so this is pretty easy. The measure of angle A is going to equal half of this arc. I'm going to write that down. The measure of angle A is going to equal half the arc BC. So half of 140, and half of 140 is 70. So this answer up here is 70. Pretty easy. Okay, number 2, solve for x. All right, you have your circle. Here's our inscribed angle. And I'm going to give you that the angle on the inside is 28x minus 12. And the arc on the outside is 200. Okay, so what you're going to do is use one of these formulas up here. I'm going to bubble this one in as well. And you just have to, and it doesn't matter on which one you use, whether you take half of the angle, whether you take half of the arc or you double the angle. Either one is going to work. I will show you both equations. Some kids will double the angle. I'm going to double 28x minus 12 and say that equals 200. Some kids would leave the 28x minus 12 as it is and cut the 200 in half. It is totally up to you on which one you solve. They both work out the same exact way. In the end, they both come up with the same answer. I'm going to go ahead and solve this one. 28x minus 12 equals 100. Add your 12 to the other side. 28x equals 112. Divide both sides by 28. X equals 4. All right, now here if you had distributed and solved, you'd end up with the exact same answer. All right, so X is 12. Moving along. Number 3, we are going to draw a circle. The center is B, and we're going to draw diameter HJ. And another diameter we're going to call AC. All right. Now, given the measure of angle JBC equals 60 degrees, and I'm going to give you one more. There's a point right here. We're going to call that point K. Just a point on the circle. All of these are points on the circle. Okay. Given that, find the following. A, B, C, D, and E. Okay. A, we're going to find the measure of arc AJ. All right, so let's label what's given first. Angle JBC is 60. JBC, that's this angle right here, is 60 degrees. Okay, so right now this is a central angle. Do you see that there is a central angle, not an inscribed? So that means this arc right here is also 60, so we're not doubling or taking anything in half. Okay, so what else do we know? Let's see, we know that this is a straight line, so these two angles have to add up to 180. So I'm going to call this angle X, and X plus 60 equals 180. Subtract the 60, X equals 120. So this angle in here is 120, which means arc AJ is also 120. All right, letter B, find the measure of angle JHC. Okay, where is JHC? JHC. Now we've talked about that before. If I trace from J, we did this on our previous lesson, to H, this is going to get messy, to C, I'm looking for this angle right in there. Okay, and There's different ways of doing it. I'm actually not going to do it the way we did yesterday. I'm going to do it the way we just learned today. Can you see that this blue line here, these two chords, intercept this arc? Do you see that here? So what's the relationship? Is this angle H, is it an inscribed angle or a central angle? Angle H, the one right here that I'm referring to, that I'm pointing to, is an inscribed angle, which means it's half of the intercepted arc. So let's write that down. The way we find that there is doing half of the intercepted arc, which is 60, and half of 60 is 30. So the angle is 30 degrees. Okay, letter C, the measure of angle AKC equals blank. The measure of angle AKC. All right, it's going to get a little messy here. A to K to C. Now, we're also going to use the fact that angle K is an inscribed angle and it intercepts this big semicircle over here. And I know this is a semicircle because this line here is 180. If this line here is a diameter, then this arc up here is a semicircle. Does that make sense? So this big arc, or just think of it, what's 60 plus 120? 180. So this arc out here is 180. And angle K is an inscribed angle, which means it's going to equal half. So how do I find that answer? I take half of the intercepted arc, which is 180, which gives me 90. So that is a right angle in there. All right. Why is it a right angle? Because it is inscribed, which means it's half of its intercepted arc. It's half of the 180. Okay, letter D, the measure of arc HC. The measure of arc HC. So I'm looking for this arc right here. Put that in pencil. In order to find that arc, I need to know an angle. Now, the angle that inscribes this arc is this angle right here, which is a central angle. What is the central angle? These two are vertical angles, so this angle here is 120 degrees. Do you see that? 120, 120, because they're vertical. Since this is a central angles are equal to its corresponding arc, so this arc is also 120. I don't have to cut in half or double anything because that's not, that vertex is at the center, not on the circle, like K was or H was. Okay, letter E, the measure of angle ABJ. The measure of angle ABJ. ABJ, that one's pretty easy. We already have it labeled. The measure of angle ABJ is right here, ABJ. We already have that labeled. It's 120 degrees. All right, that is it for this lesson.